let's before I start into the topic decision trees, I just wanted to bring up this. There is a movie called Moneyball where Brad Pitt was starring, and this movie is based on a true story where Brad Pitt plays a team manager role for Auckland Athletics. So these guys they are into football, and after they lose their match, their star players flee from their team, and now Brad Pitt has to, as a manager of the team, he has to assemble a new team with certain constraints. So rather than going with the traditional ways of choosing with the experienced players, he uh, he tries to assess the players' values based on some baseball statistics and sabermetric approach. And then even after a lot of controversy, initially the matches played by the team are lost, but later the entire team wins 19 consecutive games. So now we want to see how the data has helped, or like how the data is helpful in forming or like in forming a team or predicting a event. So for that for that prediction, one of the classification model is algorithm is decision tree. Decision tree is a classification model which is of the form of a tree structure. What it does is it breaks down a larger data set into smaller subsets of data, and it develops an associated decision tree incrementally. It is a recursive divide and conquer. It is based on a recursive divide and conquer procedure, which is a top-down induction decision tree. So the final resultant tree that comes out of this has decision nodes and leaf nodes. And leaf nodes, they have the classification or decision, meaning they represent whether, if we are talking about selecting a member into a team, they represent whether a member can be selected into a team, yes or no. And each branch corresponds to an attribute value of the node, meaning say he is good in fielding, or yes or no, or the field is a node over here and the value is yes or no. Entire decision tree algorithm is based on the information theory, and the decision tree, they produce rules which can be easily understood by common people. I'm going to the second slide. So for our example, I'll be talking about a decision tree which we can be used to predict whether a match can be played or not, given the attributes and their values. So if suppose there is a tennis match and there are 4 attributes: outlook, humidity, wind, and temperature. These are the 4 attributes and their corresponding values. So outlook has 3 values: sunny, overcast, and rain. Humidity has 2 values: high humidity, normal, windy, strong or weak, or like there is strong wind, yes or no. And then temperature is hot, mild, and cool. And the target decision, we are supposed to predict whether we can play the match, that is yes or no. In general, if there are more number of attributes, selecting the attributes which help us make a decision itself would be a big challenge. So to overcome that, we have other algorithms like principal component analysis and all. But decision tree makes our life pretty simpler. What it does is it runs based on information theory. Okay, let me go to the second slide. Next slide. Here are the values. There are like 10 odd instances, and their attributes like outlook, temperature, humidity, windy, and play. And these are the values. Decision tree, this particular classification model is called supervised learning, wherein we have a set of values. Based on these values, we are trying to understand whether the match has been played or not, and then we are trying to predict whether the match can be played in certain condition. So if you see, this is a frequency table which is giving all the information. We have information pre-hand. And when you construct a decision tree, the final output would be something like this. When the outlook is sunny and humidity is normal, we can have a match. We can play the match. There can be a match. And when when there is outlook is overcast, in all the overcast outlook, matches have been played. When the outlook is rainy and wind is weak, we can still go ahead and play the matches. So these are pretty simple, straightforward rules through which you will be able to make a prediction. Now let us see how this decision tree, entire decision tree, has been constructed. If you see outlook, this one is called the root node, and these are the branches, and the values yes or no, these are the leaf nodes. So this is a, as I said, this is a recursive divide and conquer. So each node, based on its node and their values, is being subdivided, and smaller trees are being formed until, and this is being repeated until at the end all the leaves have same values, or all the leaves have values. So as we said, it's a top-down recursive divide and conquer. So first it would go from the top node to all the other nodes, and then come up with the values and provide a tree. The process to do this is, there are 4 steps: selection of attribute for the root node, splitting up of the instances into subsets. As we said, like, the larger data set has been will be split into multiple subsets, and for each of those subsets the entire process is repeated again. And the stopping criteria for the entire process is when all the instances have the same class. The class is what we are classifying. This is class as the decision which we are making, that is, yes, the match can be played, no, the match cannot be played. Now if we come to the selection, a branch, we create a branch for each of the possible attribute value, meaning outlook, if you see the this chart, outlook had 3 attribute values, and humidity has 2, wind has 2, temperature has 2. So based on these values, the tree has been formed. And split, when it comes to split, how do you split into again some smaller tree? One for each branch extending from the node. For each of those attribute, sorry, one moment please. So for each of those attributes, a split is being done, and then a decision tree is being done. I'll move on to the next slide. The challenge over here is attribute selection. How do you select what is the attribute, which is the attribute that best gives the split? So if you look at the attributes, we had outlook, windy, humidity, and temperature. The best possible way to find the best root node is to find attribute value which has all yeses or all no's. So in our case, for outlook, for overcast, when outlook is overcast and overcast has all yeses, this will become a pure node. The pure node will help us decide what would be the root node, and then subsequently we can go for subsets, and the process is being defined again. If you see the values, whatever table we had defined, and if we split for each of those attributes, for outlook, windy, and humidity, and temperature, the matches that are being played for sunny, overcast, and rainy, and similarly for the rest of them, and only the outlook has all yeses, the rest of them do not have yeses. So outlook, when outlook is overcast, it becomes a pure node. So we start with outlook as the root node, and we start splitting, and we branch into the next level. So how exactly this attribute selection would be done? We'll be doing it through information gain. Am I clear till now? Okay, take it as yes. I'll go ahead. So the attribute selection, it is all based on information theory. This guy, he is Claude Shannon. He's an American mathematician who has given the information theory. the basic aim or what we're trying to produce is we want to have a smallest tree possible. So for constructing this tree, the heuristic we take is the attribute that produces the purest node will be the root node, and then we would go along with it. How do you decide whether it is the purest node? Is through the information theory. The node which has the highest information gain, we would be taking as the purest node. Information theory is nothing but it's a measurement of information in terms of bits. We'll not go in deep into entropy and information gain, but I'll just give you a quick summary of what entropy and what information gain is. Information gain is the amount of information gained by knowing the value of the attribute. So that's exactly what we have done in the previous slide. By knowing whether a match will be played when the windy conditions are yes or no. So each of these values would attribute whether this attribute can be considered for splitting or not. And entropy, the formula for information gain is the entropy of distribution before the split and entropy of the distribution after the split. So when a tree is split into multiple subsets, we would calculate the entropy. We will talk about entropy maybe at the end of the session. So for now, just think that this information, all these values have come from information gain. Though we are talking about bits, but the information theory still says that these bits are of decimal values. So if you see, based on our based on the information theory calculations, Outlook has the highest information gain. Hence, Outlook will become the root node. These will not be considered. And next, the same would be repeated for the other nodes. So we will continue splitting. Now Outlook has been split on Sunny, and then similarly information gain is calculated for the rest of the attributes, and till we reach the leaf node. This splitting would be continued. We'll talk about pruning at the end. Pruning is not really required as of now for the classification. So the main purpose of decision trees, like when do we use a decision tree, is when the instances are like attribute value pairs, meaning we have humidity as high and normal, windy as yes or no, outcast as sunny, rainy, and all those things. And when the target function is a discrete value is yes or no, meaning it has only two values, whether the match can be played or whether it cannot be played. One of the major problem with decision trees is overfitting. When we go with the let's go back to the main example, first example where we thought of selection team. So think of say we have upcoming Cricket World Cup, and then we are forming a team. So when we choose a team, there'll be a selection team which has several selection criteria. Based on those criteria, a team would be formed. If there are too many attributes, so saying the player who has to be selected, from where he has come, from which region, from what cultural value, or like what is the trophies which he has played, how many trophies he has played. If there are too many dimensions coming into the picture, then there is a chance that the algorithm would produce a very perfect tree. See, if you remember the previous sessions, we were talking about, first we take data, then we build a model on the data, and the data would be divided into two parts, mainly like test data and training data. So when you fit the model, when you build a model on a training data, and when you try to fit it on a test data, if the model overfits, then all the values in the test data may not be correct. So even though when there is a chance of no play, if the model is overfitting, it will show that the match is there can be a match, the match can be played. So the purpose is defeated. So overfitting is one of the problem which decision trees has. To overcome this decision overfitting problem, pruning would be pruning is being done. So what pruning does is, pruning is nothing but removing the branches of a tree. If you think of a tree, the bark of the tree is the strongest and the branches are strongest, and the twigs of the tree, the twigs connected to the branch to which the leaves are weakest. So if you want to find out the strongest branch onto which you can hang out, uh, it can be found out only when the unnecessary twigs and other small branches can be removed. For this, there is a philosophy by Occam's razor. So what it says is, you build the smallest tree possible. That is, always choose a decision tree that has the optimum combination of size and error. When we say size, the size is about the number of attributes and number of trees that are being forming. And how to prune is, will not continue to split if the nodes get very small. If there are multiple smaller nodes, they do not have much information. They do not have very good information based on which you can provide a decision. So we can ignore those smaller nodes, and then build a full tree and then work back from the leaves. That is what we have been saying. It's a top-down approach. You build a tree from top to bottom with the information gain. Go till the leaf level, and based on the class value, whether the match can be played or not, you come up recursively. That is by applying a statistical test at each of those stages. When we say a statistical test, we apply at the node level. And sometimes we can even prune at the interior node, raising the subtree beneath it up to one level. You can ignore the bottommost or the most common ones. And one of the, or like few of the most prominent machine learning algorithm that was being developed is C 4.5. This was developed by Australian computer scientist called Ross Quinlan, and there are many other different pruning methods, and it's a general technique that can be applied to any of those structures other than trees, like decision rules. I'll quickly go into the example. Okay, today I'll not be able to show you the R code, but what I would be doing is, there is another tool called Weka. So I'll give you a walkthrough of Weka, which is capable of running decision trees. Weka is a machine learning tool which is being provided by Waikato University of New Zealand. University of Waikato, New Zealand. Weka is an acronym for Waikato Environment for Knowledge Analysis. So it is pretty much as our R. R has R is a more like a programming language where you have more control and then you can explore in detail. Weka is also good. It is a Java-based application, and it is available for free. And all you do is do Google for Weka, and you can directly download Weka. All it requires is Java. It's hardly 50 or 20 MB. Yep, this is the size. That is with Java and without Java. So once you install Weka, it would come and sit in your programs, and all I have to call is Weka. So when I start Weka, I'll get a nice GUI. I think it's already started, and the same weather data, I'll show it here. So Weka has provided some data sets to play around, and one such data is this weather nominal. And to read data in Weka, it should be in ARFF format, .ARFF format. It's attribute relation file format. Okay, I'll open this. So if you see, the same thing, whatever we've been talking about, it is being represented in this format. Here we say uh, there are 5 different attributes: outlook, temperature, humidity, windy, and play, and these are the possible values for each of those attributes, and the actual instances data is this. So you define, when you say add data, Weka tool understands that this is the data. So I'll go to the Weka, and Weka has for 4 different applications. We will be talking about Explorer application. So I'll start Explorer. First thing, we have to choose the file. I have it on my desktop. So weather nominal data, and instantly Weka reads this file and says there are 14 instances available, and there are 5 different attributes, and these are the 5 different attributes, and these are the values for each of those attributes. For Outlook, there are 3 values: sunny, overcast, and rainy, and sunny has 5 instances, overcast has 4, and rainy has 5. Similarly, other instances, and this 2 colors over here, they show whether the match has been played or not. We are saying the class is play as in whether this is the decision to be made classified, whether the match can be played or not. And I forgot to mention, sorry, so the last value that you specify in the ARFF file would be the classifier value. And now that the Weka has read all the values, now we have to classify it using decision tree. So this tab over here, it shows how to classify the given data set. Now the classifier, by default there is a 0-hour classifier. There are several other classifiers, but we would as of now we will go with the decision trees. These are all the classifiers that are available, and now decision tree comes under a tree, so we will go with decision tree, and in Weka it is called J48. I've told you here it was C4.5. The C4.5 algorithm has been changed into Java version, and Weka calls it as J448. The J48 is a decision tree algorithm. Now when I said we divide a data set into training data and test data, how exactly we would check is by whether we can use it as a training data, or you can do a cross validation, or you can do a percentage split, saying if there are 100 records, you can say 60 records as training and 40 records as for test, or you can say cross validation. Cross validation, here what we are doing is a 10-fold cross validation. It divides the data into 10 parts. Each part will be taken as test data, and the remaining 1 part will be taken as the test data, and the remaining 9 parts as the training data. And those 9 parts would be used for building the model, and this first part that is being kept aside for test would be used as for testing, and this will be repeated for all the remaining 9 instances. And now I will start the algorithm. Now if I see, this is J48 algorithm, and these are some default values. This is the size of the tree, and this is the confidence level to which I can have. And this is the class I want to. This is the class which I want to classify, whether we can have a match or not. So if you see it is pretty fast. One moment, I'll scroll up. Okay, so this is the algorithm that has been run, J48, and that has been run on weather data, which has 14 instances and 5 attributes. Now after running this algorithm, what did this tree, how it has given rules is, when you have outlook as sunny and humidity is high, there will be no match at all. When the humidity is normal, yes, there will be a match. And when outlook is overcast, always there will be a match. And outlook is rainy and windy is true, like there is a strong wind, there cannot be a match. And when there is a weaker wind, there can be a match. Now the same thing whatever that we have shown in the presentation. So when outlook overcast is when the outlook is overcast, always a match will be played. And what was the second one? The other rule states is when the outlook is sunny and humidity is high, there is no match, and when outlook is sunny and humidity is normal, there will be always a match. So if I come here, when the outlook is sunny and humidity is high, there will be no match. Okay, let me do this. Okay, I think this is okay. So when outlook is sunny and humidity is high, outlook is sunny and humidity is high, there is no match. Sorry, there is no match. And when the outlook is sunny and humidity is normal, there is a match. So this is the tree. And for overcast, there is always a match. And when there is windy, it is when it is strong, there are no matches. And when it is less windy, or like there is no wind at all, there is always match. So this is how decision tree would help us create rules. And these are the values, like if you see, these are the instances which have been classified based on the data set which we have created. And this is the percentage. The precision over here is 60% of the time the values have been correctly predicted. This recall, F measure, ROC area, these are all for checking whether the model that has been built is good or not. Let me check whether I can bring up. Okay. I'll just summarize this session. Okay, so to summarize, the nodes are the test point where you check for hypothesis, and then you go for split, and then leaves are the decision points which would classify, and branches are the collection of nodes and the leaves. Advantages of the decision trees are they are fast, they are robust, and they require very little experimentation. The two main aspects of a decision tree is how do you choose how do you choose attribute to split, and where do you stop? And the best tree is the smallest tree with the smallest error that has been given by Occam's razor, and we can avoid overfitting using pruning. And why you have overfitting is like the subsets are more likely to be pure if there is a large number of values, and the information gain is based towards choosing the attributes with larger number of values, which may result in overfitting. The more the number of high values, like we saw in case of our overcast, and then outlook was sunny. So the more the information gain, you'll have more the number of pure nodes, and then this will cause model to be overfitted. When the model is overfitted, you will not be able to predict or classify. Entropy is the one which has the which gives us highest uncertainty and which has the least uncertainty. And this is a formula. We will not look at we'll not get deep into it. And what information gain talks is entropy of the system before a split, and the difference between the entropy of a system before a split and after a split. and there are two most important algorithms. That is, one is called CART, and then other one is C 5.0. C 5.0 is the successor of C 4.8, and this I